A very good day to Tokwan and everyone. We are from Group X and today we are going to present the chapter 11, Fire Hazard and Life Safety. By the way, my name is Uy Sen and my metric number is 271461. So, fire hazards are conditions that favor fire development or growth. There are three elements are required to start and sustain a fire: oxygen, food, and heat. So, why the fire is hazard? Fire are very harmful. They can destroy a huge area in a matter of minutes, and every year people die by accident from fire. Since oxygen is naturally present in most of environment, the fire hazards are usually involve the mishandling of food or heat. So there are three things that we need to remember. Fire or combustion is a chemical reaction between oxygen and combustible food. Combustion is a process by which fire converts the food and oxygen into energy or heat, and the ignition or combustion point is the temperature at which a given food can burst into flames. So there are two types of fire hazard. The first one is the exothermic, and the second one is the endothermic. So exothermic is a chemical reaction that creates heat, while the endothermic is a chemical reaction that consumes more heat than they generate. So this is the table difference between the exothermic and endothermic. So all chemical reactions involve the formation and destruction of chemical bonds between atoms. Carbon is commonly found in most flammable material. When burned, carbon is released, combined with oxygen and form the carbon dioxide or carbon monoxide. So carbon dioxide forms when there is more oxygen than the fire needs, while the carbon monoxide is incomplete combustion due to lack of enough oxygen to support the combustion. So next one is about the fire chemistry. So this is a fire triangle, and there are three principles: enough oxygen to sustain the combustion, enough heat to raise the material to its ignition temperature, and some source of food or combustible material. So for fire to continue, there must be a constant source of food, oxygen, and heat. And the flaming mode is represented by the tetrahedron that results from a chemical chain reaction, and the removal of any one element and extinguishes the fire. So there are 5 examples of PDM, form, flame retardant, PO form, MBR or PVC, or we call it the nitric rubber. So next we go to the heat transfer. So heat transfer away flow from a higher temperature to lower temperature. And heat transfer is accomplished by 3 mechanisms, which is the conduction, radiation, and convection. So for the conduction, the material needs a source of heat absorbed, and by heat raising their kinetic energy, occur when a body is heated as a result of direct contact with a heat source, primary cause for fire spread early in fire, and the fire spread by heating a pipe in one room and starting a fire in another room. The next one is the radiation. Radiation is a non-nuclear invasive and electromagnetic transfer of heat. So it transfer of heat from one mechanism to another through heat transfer, and transfer of heat energy for interviewing the medium. So for example, like we holding our hand to the sides of the candle. The next is the convection. So the convection is a heat transfer through the movement of hot gases or liquid via some medium. For example, like air or water. So the convection determines the general direction of the fire spread, and it causes fire to rise as heat rises, moving in the direction of the prevailing air currents. And we can feel heat when your hand is above a candle or match. So it produces the thermal layering, and it also can cause a fire attention between flows. So next is the heat transfers about convection, which is the thermal layering. So the thermal layering of gases is a tendency of gas to form a layer according to the temperature. The hottest gases tend to be in the top layer, while the cooler ones form the bottom layer. And smoke is a heated mixture of gas, air, and particles and it rises. So if a hole is made in the roof, the smoke will rise from the building to the outside. That's all from me. Thank you.
Good day, I'm Natalie, metric number 271467, and I will continue to explain about the remaining parts of fire hazard and life safety. So here are the fire terminology that we make use. First is the flash point, which means to the lowest temperature of the gas will burn. Second is the fire point, which means to the minimum temperature will continue to burn. And third is outer initial temperature, which means to the lowest point of a liquid or solid will self-ignite without a source of ignition. So the flash point of the flammable liquid is below 37.7% degrees Celsius, while the flash point of a combustible liquid is above 37.7% degrees Celsius. Next, there are four classes of the fire. So for the class A is about the combustible materials such as wood, paper, cloth, and cardboard. Class B is for the flammable liquids such as oil, grease, gasoline, paint thinner, and some plastic. Class C is for the fire involving engineers and electrical equipment that give off the rich white flashes from passing, and Class D is for the metal fires can continue to burn with no apparent source of oxygen. So they also have a special categories for the extremely active oxidizers or mixtures, flammables containing oxygen, nitric acid, hydrogen peroxide, solid mixer properties, and this category mainly is for the chemical substance. So next is about the NFPA 704 system. Normally, the NFPA 704 system is used to identify the fire hazard. So what is NFPA 704? NFPA 704 is the identification standard for hazardous materials emergency handling system that formulated by the National Fire Protection Association (NFPA). So in the logo of NFPA 704 system, you can see that there are four colors, and each colors represent each different category. So red is for flammability, blue is for health, yellow is reactivity, like the explosion, and white is for special information. And there is a ratings level of these categories from 0 means no hazard to 4 means most severe hazard levels. As you can see in this picture, it reached level 4 means that it becomes seriously and dangerous, while at level 6 means that it is safe and less dangerous. So next slide is about the example of the substance of each category. So you can see the example that in three categories, which are flammability, health, and reactivity. So the substance that at level 0 is almost safe. The danger level will increase with the number of classes. So the substance at level 1 still easily to handle, but from level 2, the substance at level 2 still can handle, but maybe a little bit difficult. Level 3 is more difficult to handle compared to level 2, and at level 4, it is most seriously and may cause extensive damage and losses. So here, for example, at level 4 health, means that the materials that short-term exposure will result in death or significant lasting injury. At level 4 flammability means that the materials can be quickly dispersed in the air and can be rapidly burned. At level 4 reactivity means that the materials can explode rapidly under normal temperature and pressure. So those are the example substances you can also read in this table. Just now we discussed about the level of the 3 categories. Now we see the white category. The white category is different with the others. Symbols are used in this category to represent the features of the materials. Now we can see the example symbols in this slide. So this symbol represents the material that will have a reaction when with water. This symbol will represent the materials that has oxidative properties. This is represent the material is acid or have strong acid substance. This symbol represent the material that is alkaline or have strong alkaline features. And this represent to the material that is corrosive. And the last one is the most famous symbol that we normally will see in a movie, and this symbol represents to the place or the materials that contain radiation.
My name is Tang Pui Ho and my next number is 271231. I will explain about the detection of fire hazard. So first is the thermal expansion detector. It is a heat detector. So thermal expansion detector consists of a high expansion aluminum tube which encases two insulation struts in opposing open constant point. A slow rate of temperature rise allows the heat to penetrate the inner expansion struts. Therefore, the tubular cells and the strut expand slowly until temperature level of degree Fahrenheit 935 and 194 degree Fahrenheit. The silver contrast point will cause, which indicates the alarm. Next is the photoelectric fire sensor. It is a smoke detector. So ambient opacity trigger may cause the alarm activations. Smoke particle can scatter or obscure the light sensor device since smoke produced by a fire affected the intensity of light sensor passing through air. When smoke present, the light beam scatter to photosynth device cause the detector response and fire alarm generate. Next is the ionization or radiation sensor. It is a smoke detector. So organic ionization trigger may cause the alarm activations. In ionization smoke detector, basically there are two positive and negative charges plate are consist in an ionization chamber, where in a radioactive material like americium-241 is plate. Air molecule collide with radioactive particles and eject their electron. When larger smoke particles collide and combine with positively and negatively ionized air molecule, it will cause the reduction in total charge particle. This reduction in ionization particles decrease the chamber and monitoring current which is sensed by electronic circuits and generate alarm signal. Next is the ultraviolet or infrared detector. It is a heat detector. So it's caused by the energy wavelength activations. A UV or IR frame detector consists of an ultraviolet UV and infrared IR sensors that join together in a single apparatus. UV sensors work by detecting the UV radiation emitted by the frame and are sensitive to a wide range of flammable fuels including hydrocarbon, sulfur, hydrogen, and ammonia. Next is the reducing fire hazards. There are the many ways to reduce the fire hazards. First is separate fire triangle element, which is oxygen, heat, and fuel. So another is proper storage of flammable and combustible material. Substitute with non-flammable combustible material. Separate energy sources from fuel, which is no smoking. Fire extinguishing equipment, emergency response team, disaster preparedness training, and fire prevention strategy smoking zone. All of this is the way to reduce the fire hazards. Next is the life safety. Uniform Building by Law 1984 is a very important to the life safety. In Malaysia, the Uniform Building by Law UBBL 1984 enacted under the Strict Non-Age and Building Act 1974 stipulate that all new building require to submission a plan for approval prior to construction by a principal submission person, such as professional architect and professional engineer. The UBBL 1984 stipulated the building structure requirement related to the design and specifications of material, loading, foundation, and superstructures. The UBBL 1984 also stipulated the construction requirement and the fire requirement of a building, which is egress. The egress is the action of going out or leaving a place. So the egress may include the door, the capacity of means of egress, number of means of egress, arrangements of means of egress, measurement of travel distance to exit, discharge from exit, illumination of means of egress, emergency lighting, marking of means of egress, special provision for high hazard area. All of these are included in the Uniform Building by Law 1984. Lastly, life safety means action taken to prevent the endangerment of people threatened by emergency, incident, or by activity associated with the management. So here are some fire prevention strategies, which is fire red door, flame resistant clothing, life safety program, cross-functional fire safety committee, evaluation of the program, fire emergency plan, awareness of prevention through training, reactions of employee. That's all from our group. We are Group 8. Thank you.